Hello, namaskar. So we will take today integrated rate equation for first order reaction in gaseous phase. Okay. In the previous video, what we have discussed, the integrated rate equation for first order normal reactions, which was not in gaseous phase. Why? Because why we are taking gaseous reactions? Because in gaseous phase, what is done generally is the concentration of reactant and product is taken as in their form of pressure. Okay, means if we will take their pressure, that pressure will be taken as their concentration. So that is why we are discussing for gaseous reaction separately the integrated rate equation. Okay, so suppose a reaction that is A is getting converted into B gas and plus C gas. Okay, these are all gaseous reactant as well as a gaseous product. Okay, so what we can take here is the initial pressure. Okay, previously what we have taken, the initial concentration. Okay, say like A or whatever. So here what we are taking, the initial pressure of gas, that is Pi for initial pressure. Okay, so at time t0 the pressure of gas is Pi, and of course for B and C it will be 0, and after time t, what will be the pressure of A, that is suppose Pa will be equal to Pi minus X, because here the pressure of gas A is decreased from the Pi as Pi minus X, because the pressure of B here becomes X and pressure of C also becomes X. Okay, so X small of A is getting converted into X small B and X small C. So the pressure of gas A will decrease, hence the pressure of gas B will of course increase and C will also increase, and that is why the pressure of gas A at time t, that is suppose Pa will be equal to Pi minus X. Is it okay? So now according to if we see, because we need the value of X. Okay, and for the value of X, let us take P total, that is Pt. Suppose Pt is what? P total, and P total will be equal to Pa plus Pb plus Pc. Okay, at time t, what will be the total pressure? Will be equal to pressure of gas A, pressure of gas B and pressure of gas C. So that will be equal to what? Pi minus X, this is for Pa, plus X, this is for Pb, and plus X, this is for Pc. Okay, means pressure of gas C, pressure of gas B, pressure of gas A at time t. So what we will have, this will cancel out. Okay, and the value of X we will get, or what we can write, X is equal to what? X is equal to this is Pi plus X, so X will be equal to Pt minus Pi, Pt minus Pi. So this is the value of X at time t, Pt minus Pi. Am I right? Now if we want to calculate the pressure of A at time t, because that is what we need for integrated rate equation. What is the integrated rate equation for first order reaction? The value of K will be equal to 2.303 upon T log R naught upon R. Okay, R naught is initial concentration and R is the concentration at time t. So here what we need, Pa means the pressure of gas A at time t, because initial pressure we are having Pi. Am I right? So If we want to calculate PA now, then what we can do, PA is equal to PI, okay, minus X. Instead of X we can put PT minus PI. What we can put here is minus PT minus PI. This is what we have put the value of X from here to here. Okay, so what will be the PA, or what we can write, or PI minus PT plus PI, because if we will open this bracket, this minus will become plus. So PI plus PI will be equal to 2PI, am I right? So 2PI minus PT. Okay, so this is the value of PA at time t. This is the value of a PA at a time t, 2PI minus a PT. So now we can put the integrated rate equation for first order reaction. That was what? K1 is equal to, okay, we are taking final equation, K1 is equal to what? 2.303 upon T log Pi means initial concentration of A upon PA okay, that is the pressure of gas A or concentration of gas A at time t. So what we can put here is or K1 will be equal to what? 2.303 upon T log Pi, instead of PA what we can put now? 2PI minus PT, 2PI minus a PT. Okay, so this is the integrated rate equation for first order reaction in gaseous phase. Integrated rate equation for first order reaction in a gaseous phase. So if we are having the P total and PI, P total means total pressure of all the gases at time t, okay, and PA is what? The partial pressure of gas at time t, okay. So this is how we can calculate if we are having initial pressure, that is Pi, and the pressure P total, PT, okay, PT means P total, okay, total pressure of all the gases at time t. So from this equation we can calculate K1, or if we are having K1 then we can calculate the time t taken for the completion of a reaction, like 25% or 50% or whatever. So this is the equation for gaseous phase, okay. So now let us see some of crazy points, okay, crazy points, some let us see. For T half we are discussing some crazy points here, like T half for first order reaction was what? R naught upon 2 K0. It means T half for zero order reaction, this is for zero order reaction, T half is equal to R naught upon 2K0, or what we can say, T half is directly proportional to R naught, means the half life of a zero order reaction is directly proportional to initial concentration of reactant. Now for first order reaction, FR, for first order reaction what we have calculated, T half is equal to 0.693 upon K1, am I right? It means what? The T half for first order reaction is independent of initial concentration of a reactant. Whatever concentration you are taking, it doesn't matter for the value of half life of first order reaction. For second order reaction, that is SOR. For second order reaction, what is T half T half is equal to 1 by K2, okay, 1 by K2 and R naught. This is what the T half for a second order reaction. However, the detailed kinetics of second order reaction we are not discussing here, but sometimes these things may be asked in your examination. Okay, in college chemistry, of course, we will discuss second order reaction, third order reaction as well, but for 12th level we are discussing only zero order reaction and first order reaction in details, and some half-life periods for second order and third order reaction as well. Or what we can say here is T half of second order reaction is inversely proportional to the initial concentration. R naught is inversely proportional to the initial concentration of a reactant. For third order reaction, that is third order reaction, T half is equal to 3 by 2 K3, 3 by 2 K3. K3 means rate constant for third order reaction, R naught square, R naught square. Okay, it means T half of third order reaction, or what we can say T half for third order reaction is directly proportional to 1 by R naught square. So from the value of these all T half, what we can say here is, we can say that T half of nth order reaction, nth order reaction, okay, for nth order reaction, what will be the T half, okay, is directly proportional to 1 by R naught, 1 by R naught raised power n minus 1, n minus 1. Okay, it means what? If you are taking zero order reaction, that will be equal to, or what we can say, T half for nth order reaction is directly proportional to R naught raised power 1 minus n. So this is what actually I wanted to conclude. What? The T half of any order reaction, if we are asked, then we can analyze from this equation. T half is directly proportional to the initial concentration of reactant raised power 1 minus n, where n is what? Order of reaction. N is what? Order of reaction. So if we are taking like zero order reaction, T half is directly proportional to R naught. Okay. If you are taking first order reaction, T half is directly proportional to 1. Okay, because 1 minus 1 0, 0, R naught power 0 means 1. So it means T half is independent of initial concentration. If you are taking n is equal to 2, then T half is inversely proportional to R naught. If you are taking n is equal to 3, then T half is directly proportional to R naught square. Okay, so we can calculate T half if we are having initial concentration of any order of reaction from this generalization. Okay, so these are some crazy points. Okay, crazy points we should know. Now let us see one more term which is used in kinetics is pseudo order reaction. Pseudo order reaction. Okay, pseudo order reaction. Pseudo order reaction means if a reaction seems to be higher order but follow the lower order kinetics. If a reaction seems to be higher order but follow lower order kinetics, then this term is used, pseudo first order. Okay. So there are some reactions in which the concentration of a reactant, okay, concentration of a reactant does not vary considerably at the end of reaction. Okay, it means what? The concentration of that reactant we can say is taken in excess. Okay, like some examples we are considering here. The ester hydrolysis in acidic medium. Okay, ester hydrolysis in acidic medium if we are taking, then what is done here is, this is an ester C2H5 one second, ester hydrolysis. Okay, ethyl acetate we are taking CH3C double bond O C2H5, this is an ester. Okay, in the presence of excess of water H2O. Okay, and in acidic medium, which medium? The acidic ester hydrolysis. Okay, so what we will get? CH3CO OH plus C2H5 OH means acid plus alcohol is what we will get. Okay, so the concentration of this ester is taken as 0.01 m. Okay, concentration of water is access to say 10 m. Okay, and this will get how much? 0.01 m, and this we will also get 0.01 m at the end of the reaction. Okay, if we will say the kinetics of this reaction, that is R. Okay, that is R will be equal to what? K1. Okay, because this is considered as first order reaction with respect to this one and this one. So K1 C2 CH3 COOET or H2O. Okay, this is what the kinetics is. Okay. Now see the concentration of this one at time t, means at completion 0, and this will be 9.9. Okay, this will be 9.9, means a little bit it will decrease, and that will not affect much the rate of reaction or the rate constant, and it means this is almost constant. Okay, almost constant at time t or at the end of the reaction. So this is constant, this is constant. So constant into constant, another constant, and that will be K dash CH3 COOET. This seems to be a second order reaction, but follow a first order kinetics. Hence, this is called a pseudo first order reaction. Okay, a pseudo first order reaction, or simply a pseudo order reaction. So if you are asked a pseudo first order reaction, then what we can say? A reaction in which seems to be a second order reaction, but follow first order kinetics is called a pseudo first order reaction. Or if simply they asked pseudo order reaction, then what we can say? A reaction which seems to be higher order but follow the lower order kinetics is called what? Pseudo order reaction. Another example of pseudo order reaction is like inversion of cane sugar. What? Inversion of cane sugar, like C11H what? 22O C12 sorry O11, okay, plus H2O. Okay, so if we will hydrolysis or this reaction, then what will happen? We will get what? Glucose and fructose. Okay, glucose and fructose is what we are going to get from this hydrolysis. Okay, so this is what is called inversion of cane sugar. This reaction also follow what? This reaction also follow the pseudo order kinetics. Okay, pseudo order kinetics. So this reaction is, this mixture is called invert sugar. Okay, why invert sugar? Because the optical rotation of this cane sugar is opposite from the mixture of this glucose and fructose, means the rotation of PPL is inverted in this reaction. Okay, that is why this is called inversion of cane sugar. So this is how we can discuss what we can discuss pseudo order reaction and pseudo first order reaction. Okay, I think you understand this one. Okay, ester hydrolysis in basic medium, yeah, remember. Okay, ester hydrolysis in basic medium follow second order kinetics, but in acidic medium it is a pseudo first order reaction. That you remember always, because sometimes you may confused in examination that ester hydrolysis, okay, sir told me that it's a pseudo first order reaction. So if it is in acidic medium, then only it is a pseudo first order reaction. If it is in what, basic medium, then what it will follow? It will follow second order kinetics. Okay, so this is how we can discuss the integrated rate equation for gaseous equation, some crazy points regarding half-life of that, half-life of zero order, first order, second order, third order or nth order reaction. That is what we have discussed here, and then we discussed the pseudo order reaction. So I think that's all for the day. It's enough. Be happy, keep reading, okay, and minimize the use of plastic. Thank you very much for watching. Have a nice day.